Okay, today we're going to talk about reliability and validity. And we've been leading up to this because now is kind of when things get a little bit more difficult. We start to get into a little bit more complex things, but establishing reliability and validity is kind of the heart of everything you're going to do with your research project, because if it's not reliable or it's not valid, then you're really wasting your time with your research. So when we think about reliability, it's whether a test or whether you as a measurement tool measures something consistently. Can you measure something this over time after time after time and get the same result? And that's essentially what reliability is. And there's a lot of different forms, but it's essentially a function of how much error contributes to the observed score. So when you think about that, you decrease the error in the score or the chance of error, and that increases the reliability. So you can standardize instructions, you can increase opportunities, because when you increase your sample size, you decrease the chance that that score is going to affect the total. And we kind of saw that a little bit when we were doing measures of central tendency, and we talked about the mean versus the median. And we can also minimize the effects of an external interference. And so maybe you want to standardize the room setting, or standardize the clothing, or standardize the type of pencil. Who knows what that is, but the more you can control and narrow down all of the things that potentially could affect the outcome of your score, the better chance you're going to have to have a high reliability. So if we look at the different types of reliability, you have test-retest reliability, parallel forms, internal consistency, and then inter-rater reliability. So we're going to talk through each one of these. This chart you can kind of refer back, but it gives you a good example of when to use it, how to do it, and then how you present it. So as you read through these examples, for example, test-retest, you want to know whether a test is reliable over time. So you correlate the scores from a test given at a time frame of 1 and the same test given at a time frame 2. Now, in between those two times, who knows what happened, and then you present it as the Johnston test is reliable over time at a certain percentage, so at 0.833 or 0.92. Now, the parallel forms reliability is when you want to know if several different forms of a test are reliable or equivalent. So there, you correlate the scores from one form of the test to the scores from the second form of the test. So basically, this is kind of when you're looking at, think about concussion, and you have concussion SAC test A and SAC test B. So are those showing the same results? Are they reliably predicting whether or not you have a concussion? The internal consistency, that's when you want to know if the items on a test assess one and only one dimension as opposed to multiple dimensions. And then inter-rater reliability is when two people are scoring the same test and you want to make sure that they are both seeing the same things consistently. And for me, the first thing that jumps out to my head is the balance error scoring test, which is a concussion test where the concussed individual stands on one leg for a certain amount of time, and then they stand, and sometimes they're on flat ground, sometimes they're on a pad. Now, 2, 3, 4 people may watch this individual, and every time that they break their stance, you make a mark, and you note how many times they broke their stance. Well, if everybody consistently sees the same amount of breaks in the stance, then that's a highly reliable test. So let's talk a little more about test-retest reliability. So again, we use this to determine if a test is reliable over time. And so if we take scores from test 1 and test 2, we have 10 different times that we've taken this, or 10 different people took this test at 2 different times, and we calculate the Pearson product moment correlation. And you guys know how to do that. We just did it. So R is 0.9. So in this particular example, this is a very strong reliability score. Now if we look at parallel forms reliability, we use this to examine the equivalence or similarity between two different forms. So again, if you want to do a study on memory and you ask someone to look at 10 words and then recite those words and then wait 20 seconds, recite them again. Well, if you give them the same words day after day, they're going to remember the words from just pure memory. So you may change the word and eliminate that learning effect. Well, if you do that, again, you have 10 people who took Form A, and then next day they did Form B, calculate the Pearson correlation, and you get R is 0.13. So this example, it's a very weak reliability. And if you don't remember how to do that calculation, you need to go backwards and look at that other lecture. Now, internal consistency. We want to know whether the items on a test are consistent with one another in that they represent the one and only one dimension or construct or area of interest. So, an example of high internal consistency is that all the items seem to measure the same thing. For example, if we look at this series, there's 5 items here. 4 plus 4, 5 minus something, 6 equals 2, 8 minus something equals 3. We look at that and we say, well, those are all numbers. Then we say, an example of low internal consistency, we may look and say, okay, well, there's 4 plus 4. Well, that makes sense. And then the next statement is, who is the fattest of the 3 little pigs? Well, that's not a numerical answer. It has nothing to do with this math. So we're mixing in different things, and so we kind of ruin this internal consistency of what we were trying to show. Now, one of the things that we must do is learn how to use Cronbach's alpha. Now, you don't have to master it. You don't have to have you don't have to be Superman in learning how to do this, but you need to know where it is and how to use it and when to use it. So if we're developing a test of attitudes towards different types of healthcare, and you want to make sure that the set of 5 items measured just that and nothing else, you're going to look at the scores for each item and see if an individual score correlates with the total. So we might expect that people who scored high on certain items, so if I check I like my HMO, okay, they're going to score low on I don't like spending money on healthcare. Okay, that's what we want to be consistent. So if you are a person who I love having clean clothes, you are not going to enjoy eating ice cream in white pants and a white shirt. So again, you're determining the reliability there of a data set, and Cronbach's alpha must be used. So what is this? This is not Pearson. This is not Spearman. It's used to correlate the score for each item with the total score for each individual, and then comparing that with the variability present for all individual score items. So basically, it's a big long explanation, and you're thinking, I have no idea what you're talking about. Basically, any individual with a high total test score should have a higher score on each item than someone who has a lower total test score. So if I have all 4s and 5s versus all 2s and 3s, there should be a difference there. Now let's look at an example, and this may help kind of clear this up. So if we look at our 10 people who took this test, and then item 1, item 2, item 3, item 4, that's what they chose. And so if we do Cronbach's alpha, and what we have on the right is a little video. So you see in this Excel spreadsheet that we have the same grid that you have on the left. And as we look at it, we can say, all right, we know that we can kind of do a Cronbach's alpha. So we go to our statistical tab and we look, and lo and behold, there's no Cronbach's alpha. You say, okay, well, let's just go to the straight data pack that we all downloaded, and we look, and you know what? There's no Cronbach's alpha. So what do? Well, there are other options that you can take. You can go to a website, or you can download this thing called Real Statistics. You hit Control-M, this pops up, you click on Reliability, you go in and make sure that Cronbach's alpha is selected. You can see other options there, and then you have to enter in the range. And for some of you, this will be very new. So you're going to use $, $B1, colon, $F, $11. And that gives us the entire range instead of highlighting. Typically in our other sessions, we just highlight the area and that throws in the distribution. Well, you have to do that manually. So if you're not familiar with that, you can email me and I can let you know, or you may find another method that computes this easier. But what we see is Cronbach's alpha is 0.237 or 0.24. So the coefficient of alpha here is 0.24, which is really not very good. It's very weak. And so if we look again at the data set there, Cronbach's alpha tells us that there's not a very reliable test there, or our results there are not very reliable. Now, before I go on to enter rate of reliability, I just want to say that Cronbach's alpha is used with that specific instance, but we're not going to deal with that a whole lot. But if you do, you can use SPSS, and it's a little bit easier to use. but yeah, that's something you have to pay extra for. And we're trying to teach you how to use everything through Excel so that you don't have to pay extra for that statistical program. However, you can go online, and there are Cronbox Alpha calculators where you enter in the numbers, and it will calculate it for you. So if this is something that you need to use to establish reliability with your research, I'll work with you. Worst case, you can send the data to me, and I can run the stats for reliability on my SPSS. So with that being said, let's move forward to inter-rater reliability. So this is how much two raters agree on the judgment of some outcome. So again, two people are watching, maybe watching TV, and they're making a note every time the audience laughs. Well, every time the audience doesn't laugh, they leave it blank. So the more similar the ratings of these individuals, the higher the level of inter-rater reliability. So if we look at two rounds, or two people, so I've got BJ and BL, and every 10 seconds, we're making a note whether someone laughed or not. So the two raters score, and actually this example is a social interaction example. So I'm trying to notice from a customer service rep standpoint, we've now given a customer service training session, and two individuals are watching one other individual interact with their clients. Well, every time they do something that's positive, they get an X. Every time they do something that's negative, they get a dash. So when we look at what is the rating consistency across a 2-minute period, broken down to these 10-second blocks, what we find is there were 7 where we both agreed, 3 where we both agreed, 1 was yes, 1 was no. Okay? So what you want to remember there is it's not the total number of positives or the total number of negatives, it's the total agreements. And so there were 10 total agreements and only 2 disagreements. And so what we do is to determine the inter-rater reliability, it's very, very easy. You take the number of agreements divided by the total number of possible agreements. So 10 divided by 12 is 0.83. So the inter-rater reliability coefficient is 0.83, which is very high. This one is very, very easy. People make mistakes often because they'll look at, I'm going to get all the checks or all the minuses, and they add those up. They don't look at the agreements. It's all about how many agreements you have. So there are some other methods of reliability that we're going to talk about later, but I don't want to throw too much at you, and that's intra-class correlation, inter-class correlation values, ICC values with confidence intervals, ANOVAs, and repeated measure ANOVAs. ANOVA stands for analysis of variance. So we're gonna get to that, but I want to give you this kind of little bites at a time. Now, just because you establish that a test is reliable, that doesn't mean that it measures what it says it's going to measure. So if we look at this test, 16 plus 12, 21 plus 13, and 41 plus 33, if that's the test we use to measure the spelling accuracy or the spelling ability of second graders, the reliability of that test is very high. But it has no validity, because what does math have anything to do with spelling? Okay, so now we've got to kind of move on to the next step, and that's validity. And validity is a property of an assessment tool that indicates that the tool does what it says it does. So reliability tells us that we can get the same score over and over again no matter who grades or who evaluates the situation. Validity tells us that the test that we have asked someone to take is going to measure what we say it's going to measure. A valid test, again, measures what it says it's going to measure, and there's 3 main types, and that's content, criterion, and construct. So if we look at these, again, content, criterion, and construct, the first one, when to use content, well, that's when you want to know whether a sample of items truly reflects the entire universe of items in a certain topic. So the way you do that is you ask an expert, and this can often be referred to as face validity, but you may want to do an evaluation of branding scores or branding identity. Well, the way you do that is you go to someone who's an expert in branding identity. You ask them, hey, does this test, do these methods provide a process where I can measure effectively people's perceptions of branding? And if they say yes, that's great. You got it. Okay. Criterion validity. This is when you want to know whether test scores are systematically related to other criteria that indicate that the test taker is competent. So that's when you correlate the scores from the test with some other measure that's already valid. So maybe you develop a test that's going to measure concussion symptoms, and you have a similar test that already is established as being valid. Well, you can run a correlation between those two tests, and if the correlation is high, you can say that your test maintains validity, criterion validity. Now, construct validity, this one's pretty tough because this is when you start to really get down into variables and what exactly is affecting, or all the things I'm trying to measure, do they really affect the theory or the idea that I'm trying to prove or disprove? So let's talk a minute more about content validity. And again, this is most often used with achievement tests, and so you look at SAT scores and GRE scores and the TCAPS test here in Tennessee, whatever it is, but you can also use it for any other kind of survey that's going to measure something that you can find an expert in that field and say, hey, does this measure what I think it does? And sometimes we talk about face validity, and hopefully when you find this expert, if they say yes, you're good to go. But if they say no, they're going to provide feedback and how you can manipulate your survey or your questionnaire. And if they do, then you go back and you present it. And when they say, yes, this is good, because you've identified them as an expert in their field, then you're good to go. Now, moving on to criterion validity, does a test reflect a set of abilities in a current setting or future setting? And so this we need to break down into two different areas. And that's concurrent validity, which means that it's taking place right now, versus predictive validity, which is something that's taking place in the future. So concurrent validity. Okay, let's talk about this. Well, let's say that, for example, you're hired by a culinary institute, and this institute wants to design an instrument that measures skill. Well, part of the training has to do with straight knowledge, and so that's going to be left with some kind of aptitude test. Well, you want to develop a test that does a good job of measuring the actual skills. Now you want to establish some level of concurrent validity. So to do this, you design what's called a Cook test, and so you make this up on your own. Maybe the scores are going to range from 1 to 100. There's a set of 5-point items across a set of criteria, which could be presentation, food, cleanliness, whatever you want, that each judge will use. As a criterion, and that's the key, is you have another set of judges rank each student from 1 to 10 on overall cooking ability. Then you simply correlate the scores from the Cook test that you made up with the judges' ranking. So if the validity coefficient, which is a simple correlation, is high, you're good. If not, you're back into it. So let's think about what I just talked to you about. And I wanted to be very detailed in reading that because I want you to go back and read through it, because on first read, you're going to think, what are we talking about here? So basically, we have a scale, and we evaluate them. Judges are going to evaluate them on 5 items. Maybe it's 1 to 5, whatever it is, 1 to 100. And so they're going to finish, and they're going to be evaluated, and you can rank them. And so after the Cook scale, you rank all of the cooks. Then you have someone come in and rank the cooks on their cooking ability. Well, if those judges' rank order is similar or correlated to the rank order from your scale, then that is an indication that, yes, we have concurrent validity. Now, predictive validity, okay, let's say you're at that same cooking school, and they're thinking, and they're going along, and all of a sudden you're interested to know how well people cook, but in the test predictive validity as well. So now the criterion changes from here now in that one that the judges give and then one that looks to the future. So basically, how well do the results of this school, or the people who graduate, how well are they going to cook? Predictively, do the people that come out of this program, do they produce good cooks? Well, now we've got to find a test that predicts success. Okay, so we're looking 10 years down the road. So we have to establish a predictive validity of the Cook test. So you go back, you look at the graduates of the program, who's been out, who's been cooking for 10 years, and then you got to administer a test to them. The criterion that is used here is their level of success. And you use as measures, number 1, whether they own their own restaurant, number 2, whether it has been in business for more than a year. Okay, and we use previous quantitative data that show the failure rate for new restaurants is more than 80% within the first year. And then we look at the rationale of, if this restaurant is in business for more than 1 year, then the chef must be doing something right. Well, to complete this, you have to correlate the Cook score with a value of 1, okay, if the restaurant is in business for more than a year, and with previous years, 10 years earlier, to the Cook score. So a high correlation coefficient indicates predictive validity. A low correlation score indicates a lack thereof. Now again, we're going to get into something very similar to this when we're doing regression. Some of you may have no interest in that. I'm going to put it up there as an option. You can look at it if you want to. But when we think about predictive validity, again, you may look at a score and you say, well, I'd like to come up with a score to determine whether this certain combine set, like I'm going to evaluate players or I'm going to evaluate coaches on these 5 items. And when I evaluate these 5 items, if their results are high, the predictive value for them to move on into higher roles is correlated positively, and it's very valid. So again, what you're going to do there is you're going to come up with some kind of measurement tool, and you're going to correlate it to if you're going to evaluate these coaches now, and then how would you evaluate them later. So go back in time, look and see how that relates, and then you can run that correlation and get a good indication that if coaches meet certain milestones, probably is a better word, if they meet certain milestones, then they are predicted to be more successful down the road. This is very common when you think about rehab. And while I'm talking about this, all I can think about is ACL reconstruction, because we know that there are certain criteria that must be met within the 5 and 6 week mark, because if you show deficiencies at the 5 and 6 week mark, you're going to see those same deficiencies at the 5 month mark. And this is not hocus pocus. This is legit, proven time after time. And so this is where we get this predictive validity. If this is confusing, that's okay. Most of you are probably confused with this. We'll work through this if this is something that's going to be applicable to your study. Now, the last thing is construct validity. And if you thought the other one was hard, wait till you try to understand this, because basically this is the most difficult to establish. It's based on some underlying construct or idea or theory. Most of you are not going to go this route, but if you do, we can look at an example. I'm going to let you read through this, but essentially this is looking at what are the areas that can affect aggression. So if you have what's called the fight test of aggression, so you make this up. An observational tool consists of a series of items. It is an outgrowth of your theoretical view about what the construct of aggression consists of. So therein you should already ding, ding, ding say, wow, I've got to come up with a good definition or theory about what aggression is. You know from criminology literature that males who are aggressive do certain types of things more than others. For example, they get into more arguments, they are more physically aggressive, they commit more crimes of violence against others, and they have fewer successful interpersonal relationships. So all of that has been previously established. Well, the fight scale includes items that describe different behaviors, some that are theoretically related to aggressive behaviors and some that are not. So once this fight scale is completed, you examine the results, you determine whether the positive scores on the fight scale correlate with the presence of the kind of behaviors you would predict given your theory. Now, you don't correlate with the kinds of behaviors that you should not be related, such as right-handedness versus left-handedness, preferences for certain types of food. Right? If the correlation is high for the items that you predict should correlate and low for the items that should not, then you can conclude there is something about the fight scale that works. Now, again, this is not easy. So, for those of you that want to tackle this, we'll do it. I'll run down the rabbit hole with you, and we'll chase this thing down and figure it out. But understand, this is very difficult for a first-time research project. Now, what if you cannot establish validity? Well, have you gone back and re-examined your tests? Because oftentimes your measurement tool may need to be manipulated or massaged to go back and be reliable. How well do I expect the responses to these questions to relate to the criterion? So if we're looking at criterion-based, we want to make sure that when this expert says, well, it's not really related, well, we need to do our homework and make sure that we can relate this as much as humanly possible. And then if we're doing some construct or parallel forms, not parallel forms, but construct validity, we're looking at, are our definitions correct? And so when we're looking at the definitions in our validity measures, we want to make sure, again, that we are very clear, very concise, and we've got this thing hammered down. Something that's pretty cool is, you've read about the relationship between reliability and validity throughout. Maybe not in this chapter, but in this book. there's a very cool relationship out there, and you may see it somehow, and that is that the maximum level of validity is equal to the square root of the reliability coefficient. So if we have a reliability coefficient for a test of mechanical aptitude that's 0.87, we can take the square root of that, and the validity coefficient can be no larger than 0.93. If that makes sense. So now, if we get a validity coefficient that's 0.98, we've done something wrong. But if we get a validity coefficient of 0.9, that's awesome. I mean, that's really, really close. So keep in mind that you can do that. What this means in tech talk, okay, is the validity of a test is constrained of how reliable it is. And again, if you go back and look at that, again, if you get 0.98, you've done something incorrect. So if you come up with that reliability coefficient, just take the square of that, square root, and you know what your max ceiling is for your validity score. Now, right now, that's enough on this stuff. I want to give you a chance to kind of digest some of this, practice some problems, look around, see what you can find, ask questions if you need to, and I'm going to put some other things up on using ANOVAs and using intra-class correlations. But we're now at that point where we need to start talking about quantitative design, and you guys are very familiar with this by now, but now's the opportunity to really kind of put this together and see what you can figure out. So if you have questions, let me know, but that's all for now. Thanks.